A sample space is the collection of all possible outcomes for an experiment. An event is a collection of outcomes for the experiment. This is a subset of the sample space. So you can see here listed out are all the possible cards in a deck. These cards right here, if they were in color, would be black. And the name of these cards is spades. So if you're already very familiar with that, you don't need to write that down. These are red, and these are hearts. We call these the hearts for very obvious reasons. Not as obvious, we call these the clubs. Clubs are black. And then finally, we have diamonds. Again, fairly obvious. Diamonds are red. So many different events can be associated with this card selection experiment. List the outcomes constituting each of the 4 events below. So event A, the event that the card selected is the King of Hearts. So you have 2 options on how to write these out. These are outcomes, not probabilities. Okay? So what are the possible outcomes for a King of Hearts? Well, that's only the King of Hearts is the only possible outcome there. And then the next event says the event that the card selected is a king. Now you can have a king in any of the suits. You can see those here. King of spades, hearts, clubs, and diamonds. So you can draw that out or you can write it out. It's up to you. So I'm going to draw it out because it's kind of fun. The King of Spades. It's fun to try and figure out how to draw a spade.
It's an upside down.
I think that it's better to draw a little triangle at the bottom. And then the King of Hearts, the King of Clubs, and the King of Diamonds. So that would be your sample space for the event that the card selected is a king. Event that the card selected is a heart. Thankfully, they said hearts and not spades on this one, so we're just going to list out each heart. Each card that is a heart. Ace of hearts, 2 of hearts, 3 of hearts, 4, 5, 6, 7, 8, 9, 10, J for Jack. So from 10 it goes to Jack, Queen, King. The event that the card selected is a face card. So, face cards. How many face cards are there for hearts?
3.
Good. So total of 12, 3 for each suit. So we can draw that out. Starting with spades. So we have, starting with the Jack of Spades. Let's try this. Jack of Spades. Queen of Spades. King of Spades. Jack, Queen, King of Hearts. Jack, Queen, King of Clubs. And Jack, Queen, King of Diamonds. So then, why don't you read Venn diagrams?
Venn diagrams. It's named after English logician John Venn, 1834 to 1923, are one of the best ways to portray events and relationships among events visually. The sample space is depicted as a rectangle, and the various events are drawn as discs.
Pause. Please underline. The sample space is depicted as a rectangle and the various events are drawn as discs or other geometric shapes inside the rectangle.
In the simplest case, only one event is displayed as shown in Fig 4.8, with the colored portion representing the event. And then there's a nice picture of the man with the beard.
His name is John Venn.
No shade.
Raise your hand if you've heard of a Venn diagram. Cool. No? Yes? Okay. Everyone's heard of a Venn diagram. All right, so Venn diagrams, like it says, one of the easiest ways to represent probability and events visually. So we have a few examples to look at here. Looking at example A here, this is a visual image of an event, not E. So what are the chances of not getting a heart? Let's say the event is getting a heart, and I want to get not a heart. It would be depicted with a drawing like this. So we'll fill in the blanks. Each event has a corresponding event defined by the condition that E does not occur. That event is called the complement of E, denoted parentheses, not E, capital letter E. Event not E consists of all outcomes not in E. So that would be all of my spades, all my diamonds, all my clubs, everything not a heart. Picture B then. With any two events, say A and B, right? Let's say event A is drawing a heart, event B is drawing a 2. We associate the two events. They're overlapping. You can see in the diagram. One new event is defined by the condition that both event A and event B occur. It's kind of a lot of events going on there, right? So a new event is the event that A and B happen, both happen. And it's denoted A and B, parentheses, capital letters. So events A and B, or sorry, event A and B consists of all outcomes common to both event A and B. So you can see that just the overlap portion is shaded in picture B. And then C. The other new event associated with A and B is defined by the condition that either A or event B or both occur. So at least one of the events A and B occurs. This event is denoted, parentheses, capital A, the word or, capital B, parentheses around it. And consists of all outcomes in either event A or event B or both. And as you can see, both circles are entirely shaded, including that overlapping piece in the middle. So event not E, we're just going to write C, which picture above? A. CA above. How about B? What should we see? A or B? We'll see C above. No reason to reinvent the wheel here. And then for C, it says event A and B, so obviously we would see
What about C number 2?
B above. So A and B and C, to represent that using a Venn diagram, you may want to watch me first here. So you would actually draw 3 circles overlapping within a rectangle. And labeling those A, B, C. The part that we can shade is the part that is overlapping all three. Okay, so one way to do this well, it's just sometimes people have a hard time seeing where they all overlap, so you're always welcome to use some colored pencils to see that. So if I say event A is yellow and event B is blue and event C is red. You can see that the area where they all overlap, where it's red on blue on yellow, is this section right here. Okay, it's always an option to grab some colored pencils. So the part that you should shade if you don't have colored pencils is just this part that's overlapping all three right there in the middle. For A or B or C, draw that same set of 3 circles in a rectangle, labeling A, B, and C. And this time, we shade in all the circles, since it says or. So far, so good? Venn diagrams, events, sample spaces. So then, example 2, when one die is rolled, just one. You've got 6 possible outcomes, right? 1, 2, 3, 4, 5, 6. So list the outcomes constituting these different events. So what are the possibilities that the event the die comes up is even? 2, 4, and 6, right? We're listing all possible outcomes. B being the event the die comes up for, or more. And that's the key. And this is where critical reading is so important. You probably saw that in 4.1. 4 or more would be 4, 5, and 6. And then event C is the event the die comes up at most 2, which would be what? 1, 2. So that's at most being the key phrase there. And then the event the die comes up 3. 3. That's it. Hey Ben, you hold off on that. You hold off on that. It's kind of noisy. Okay, read this for me, please, Zach, Ethan.
Mutually exclusive events. 2 or more events are mutually exclusive events if no 2 of them are outcomes of common.
Great. So this is unique from what we saw on the previous page because they don't have anything in common. This is an example of mutually exclusive events here, A and B. Nothing in common. So if I say a face card that is an ace, one event A is face card, another event B is getting an ace. Can they both happen? Is there any overlap there? No. So mutually exclusive. Versus having events in common. That's with 2 events. Jump down here to 3 events. Mutually exclusive is only when they all 3 events have nothing in common. So you can see here this would be the most extreme, not mutually exclusive with 3 events. But even if just 2 of the events overlap, it's not mutually exclusive. They're not mutually exclusive. So let's take a look at an example of this. You've got these different events. You read this for me, please, Allie.
For the experiment of randomly selecting one card from the deck of 52, but C equal the event a card selected as a heart, D equal the event the card selected as a face card, E equal event the card selected as an ace, F equal event the card selected as an 8, and G equals the event the card selected as a 10 or a jack.
Great, thanks. So which of the following collections of events are mutually exclusive? C and D. So let's draw a circle C for event the card selected as a heart. So picture all of your heart cards in that circle. And then event D, the event the card selected as a face card. Are there any hearts that are also face cards?
Yes.
Yes. So that means we can draw these two circles overlapping. We know that this is the region we're talking about, and therefore this is not a mutually exclusive event. So we can put an X over A. C and E. So C, again, all of our hearts are in C. Event the card selected is an ace. Is there any overlap there? Is there an ace of hearts? Yes, there is. So we have an overlap here. C and E overlap. They are not mutually exclusive. D and E. So D, I'm picturing event the card selected as a face card. I'm picturing all my face cards. Jack, Queen, King of all suits. And then E, event the card selected as an ace. No overlap. These two are mutually exclusive, so I can circle that one. D and E do not overlap. Can't have an ace card that's a face card.
Was there something that was supposed to be at the end of F?
D, E, and F.
I think it's just that, like,
And event G is what that and is for. The last event was G.
Okay.
D, E, and F. So we got our D event is face card. E, ace. No aces that are face cards. And F, 8. No 8s that are face cards or aces. So these are, this is an example of 3 events that are all mutually exclusive. There's no overlap there. And then E, so we have D, E, and F. We already know D, E, and F don't overlap, so we've got D. Let's look at G. What is G? G says the event the card selected is a 10 or a jack. Are there 10s or jacks that are also face cards? Yes. So I'm going to overlap my G with D a little bit. What about E? Event the card is selected as an ace. Is an ace a 10 or a jack? No. So that means that remains on its own. E remains on its own. And then F, event the card selected as an 8. Could an 8 also be a 10 or a jack? No. So F is here. Are these mutually exclusive? No, because if there's any overlap among any of the events, we cannot consider those mutually exclusive. And that concludes our notes on events, sample spaces, and relationships.